This is a video for getting us ready for problem 3.1, which we'll do in class tomorrow. So what are we learning about? This night notes video is going to get us ready for something called prime factorization. We're not quite there yet. First, we just want to investigate this puzzle we'll be using in class. There's a puzzle that's going to help us find factor strings. So strings of numbers. Let's talk about that. A number may be the product of many different pairs of factors. So sometimes we have pairs of factors that will give us a product. Here's an example. Let's talk about the number 100 for a moment. What are different ways we can make 100 with pairs? Well, we can say 1 times 100. We can say 2 times 50, 4 times 25, 5 times 20, or 10 times 10. Those are pairs. But what's neat about math is sometimes we can find strings of factors more than just 2. So still dealing with the number 100, here's another way we can get 100. We can say 2 times 2 is 4, 4 times 25 is 100. That's a string with 3 factors. We can have a string with 3 factors that gets us 100, but in a different way. Here's another way. 2 times 5 is 10, times 10 is 100. Sometimes we can get really long pairs. This is supposed to be 5. We could say 2 times 2 is 4, 4 times 5 is 20, 20 times 5 is 100. So all of these are examples of factor pairs and then strings of factors. I have a definition of what a factorization is, and I took it right from your book. A factorization is a product of numbers, perhaps some repetitions, that means some of the numbers may repeat, resulting in a desired number. A number can have many factorizations. For example, 2 factorizations of 60, here's a factor pair, 3 times 20, or 2 times 2 times 15. So, similar to what I just explained. Now, grab this one. Let me get rid of this, so it's not in the way. You can use factor trees. So one of the neat things about learning about factorizations is you can use these things called trees. And I think students typically like this. It's kind of fun. It says you can use factor trees to help you find factors of a number. So example, 100, if you break it down, you can say, oh, here's a factor pair, 2 times 50. Or 100, break it down, 2 times 50, and then we can break the 50 down into 5 times 10. So now we have a string. It's 2 times 5 times 10. So this one was 2 times 50. That's a pair because there's 2. This one is 2 times 5 times 10. This is a string of 3 numbers. And then this is the coolest one of all. 100, break it down. 4 times 25, we can break the 4 into 2 times 2, and the 25 into 5 times 5. So then we're left with this long string of, 2 times 2 times 5 times 5. And really you could write that like this, 2 times 2 times 5 times 5. And that is called a factor string. So where are we going with this? Well, we're going to use factor strings to help us in this game, okay? But let's practice a couple before we go any further. Let's make some factor strings for these 3 numbers. Now, what you see right here is taken right from your notes packet. So you might want to open your notes packet so that we can write the answers or some possible answers for these 3 numbers. So next to each number, create a factor string. So looking at this, next to each number, create a factor string. I just did a pair for 48, 2 times 24, and obviously there could be others. for 100, 2 times 2 is 4, 4 times 5 is 20, 20 times 5 is 100, and then 840, remember this number because this is going to be your lucky number for this game, 840, and there's some ways, there's lots of different ways we can get 840. Here was one way, I used a factor pair, 420 times 2, or we could say maybe 210 times 2 times 2, or 105 times 2 times 2 times 2. They will all give you 840. So keep 840 in mind. So why are we learning this? We're learning this because we're going to be playing a game in class where we're going to be trying to find factor strings. We're going to be looking for strings of factors, and we're going to try to find as many as possible. That's going to be the game. All right, so this is problem 3.1, and this is what it looks like. And you'll be using this puzzle. So you'll label it in your spiral just like we always do tomorrow when you're in class. You may even work ahead and do it now. It says make a list. It's going to say make a list of factor strings for 840. Order the strings by number of factors. So we're going to make a list, and we're going to see if we can make the longest list possible. So our list, we may have strings that have 2 factors. We may have more than one. We may have a list where we have strings where there's 3 factors, 4 factors, 5 factors, maybe even 6 factors. So one of the ways to find 840, they have one here as an example for you. You might go 5 times 42 times 4. So that would be an example of one with 3. 5 times 42 times 4. Here's another example of a pair, 120 times 7. So you may write 120 times 7 on your paper. I'll help you make this table in class. And then you need to find any other pairs or strings that you can. Okay? So that's what we're going to be doing. And here's what the grid will look like. And you're going to try to find as many ways as possible, and you can use a calculator. So a calculator is usable. I hope this video helps you get ready for problem 3.1.